Hey everyone, it's Mr. Smith again. This is our last, this is part 4 of the examples I was doing for reviewing one-step equations. My intended target is grade 9s, but this would also benefit grade 8s. So this is kind of like part 2. I've chose 4 fraction questions. Part 3, I covered the first 2, and I'm going to cover the last 2 in this section. So let's get started. So we have negative 7/9 is equal to r subtract 5/9. All right, well, what's one thing we notice right away? At least we have the benefit of having common denominators already, okay? Because we know that subtraction, if we're anticipating and kind of predicting and looking ahead, we are anticipating that if we have subtraction, we're going to have addition as the opposite operation. And whenever, of course, you're adding or subtracting fractions, you need to have a common denominator. So let's actually have a look at that then. So if we're subtracting 5/9, and the goal of algebra is to get the variable by itself, then we need to deal with this subtraction of 5/9. The way to do that, of course, is to add 5/9 to both sides. Okay, so we're going to add 5/9 to both sides. All right, so what happens here? Just going to switch this color. Let's go with orange. Okay, well, over here, this cancels out to be a 0 pair. Now, the other reason I chose this example is because, again, the variable's on the right side. And I wanted to remind you again that, yes, it's okay to have the variable on the right side. All right. So what are we left with on the right side? We're left with our variable. Okay. We're left with our variable. So then that means we got to deal with whatever is happening over here on the left. So we have negative 7/9 plus 5/9. Okay. So, well, we already have the common denominator, so at least that saves us a step of having to search for one. So we can just do a simple rewrite here. We've got negative 7 plus 5/9. Again, I like to emphasize, this is my favorite step. I love it when students show me the step. It shows me a number of things. Number one, that the 9 is common. It only needs to be written once. And it's showing me that you don't add the 9s or subtract the 9s, okay? The 9 is left alone because it's a common denominator. Really, your understanding of fractions comes from your understanding of common denominators, right? This is not a number to add. This is just how the pie is sliced, okay? If we drew this out in pie slices, we know that our pie is sliced into 9s, not quarters, not halves, not thirds, not 12ths. Okay, so we've got negative 7 plus 5/9 is equal to r. If we do the top here now, we've left with negative 2/9 is equal to r. Okay, so of course we can check that. Let's use blue here. So checking it means take the original equation, okay, and we are going to swap in, right? We now have something to substitute in. We have negative 2/9. Sorry, that's a wonky looking negative sign. Subtract 5/9. Okay, well, let's kind of simplify this on the right. We can write out one common denominator, and we have negative 2 subtract 5. All right, well, again, this is integer rules. Okay, so I'm just going to deal with that numerator over here. Okay, let's use pink. Okay, just from the numerator perspective, so the numerator, we have negative 2 subtract, and since there's no sign on the 5, it's considered to be a positive. So we can start, subtracting this the way this is. We could use a number line. We could use integer chips. We could just count backwards on our fingers. But essentially, what are we doing? We're taking away warmth. It's already minus 2 out. This is our starting temperature. The first number is always the start. It's minus 2 out, and we're taking away 5 degrees of warmth. That should equal negative 7. Now, the other way to rewrite this is, we know that, I'm just going to write it down here, subtracting a positive is the same as adding a negative. Okay? So subtraction becomes addition. So in other words, these signs just exchange places. Okay? I tend to favor addition a little bit. I just love the fact that it's negative 2 and negative 5. They're on the same team. They join sides, they join forces, and a -2 plus a -5 is equal to a -7. Okay? So back to here. And what have we got? Well, we've got -7/9. Okay? All right, so again, one of the things I wanted to point out is, yes, it's perfectly fine to have the variable on the right side. There's nothing wrong with that, okay? And you have to get used to that, because for those of you, especially in grade 9 going to high school, they're not always going to just, they're not just going to write stuff out like this. Here, I'll just do this in black. They're not going to make it, we all have this sort of bias towards left to right because we read the English language left to right. But not every question in high school is going to be set up like this, where, oh, look, the variable's on the left, and we're kind of used to being on the left because there's a billion questions in junior high written with the variable on the left. Well, it doesn't matter. That's all I'm saying. It doesn't matter. This is a perfectly acceptable form. All right, enough yammering on about that. Next question. All right, so I saved the best for last, because if you notice, I'll just leave it in black ink for now. What have we got? Two different denominators. And because it's subtraction, which means I'm anticipating there might be addition in my future, I'll have to deal with the fact that these are different denominators. What else am I dealing with? What's the other thing I notice? You know, teachers love asking this question. What are you wondering? What do you notice? Well, I notice that I have a mixed number, right? I have a mixed number. So sometimes in algebra, before you even think about tackling the actual question, sometimes you need a bit of a rewrite, okay? The rewrite is intended to be to simplify the work that you may have to do, okay? So in other words, I'm not worried about isolating the variable right now. I don't care about getting the variable by itself. What I want to do is take this, it's going to be negative, and it's going to be negative no matter what. What I want to do is, see, look, there's 1, there's 2. This mixed number has 3 parts to it. I would suggest to you the fraction's easier if it only had 2 parts to it. So let's convert it. Let's go from a mixed to improper. Improper. Okay. So if you recall how to do that, what you do, of course, is you take the denominator, you multiply it by the big number, and you add the top. So 1 times 6 is 6, plus 5 is 11/6, and the original sign was a negative, so that doesn't change at all. You don't ever change the sign just because you're going from mixed to improper. That the sign has nothing to do with it. You keep the sign as is. So this is 11/6. Okay, so all I did was a rewrite. I haven't done any steps to isolate for the variable. I'm just rewriting this question so it looks a little simpler. Okay, so I believe this was the color. So I've got 9/2. No, it wasn't, but doesn't matter. So I got 9/2 is equal to b minus, I'm just going to write that minus a little bit sort of in the more normal position, minus 11/6. 11/6. Okay, so what are we going to do to both sides? Well, the question starts with subtracting 11/6. So why not add 11/6 to both sides? Okay. Notice I'm focused on isolating for the variable. I don't care about denominators being common yet. Okay, that can come later. You kind of have to do one thing at a time, and you have to prioritize. So, of course, our old and unbreakable rule is whatever you do to one, you do to the other. Subtracting 11/6 and adding 11/6 will zero that out. That's the whole point. Then we're left with b. We have 9/2. Whoops. 9/2. You know what? I'm just going to write it over here because obviously my face is interfering with it. We have 9/2 plus 11/6 is equal to b. Okay? 9/2 plus 11/6 is equal to b. Now we're going to worry about our common denominator. All right? So if we go, let's do green. So if we count, now I know a lot of you, I mean, this is a fairly straightforward fraction, or common denominator situation for grade 9s, but I'll just show it anyways. So if we count by 2s, and if we're going to count by 2s, Mr. Smith, let's not skip counting by 2s. 2, 4, 6, 8, 10. And if we count by 6s, 6, 12. Well, I don't really need to go any further. Obviously, the common denominator, the lowest common denominator is 6, which means I don't have to do anything to this. Like right here, I'm good. Now, over here, obviously, I'm going to have to times this by 3. Okay? You focus on the common denominator part first, and then the numerator, well, whatever you did to the bottom, you have to do to the top. But it's not the numerator that determines anything. It's the denominator. You have to get this denominator to match this denominator. And we've done that. So 2 times 3 is 6. 9 times 3 is 27. 27 over 6 plus 11 over 6. Here comes my favorite step. This is when students like to, score brownie points with Mr. Smith when they show this step. I love this step. Okay, it shows me that the common denominator is actually common, and you don't add it. This is not going to be 12. Okay, so you got 27 plus 11. That's equal to 38. So our answer is 38 over 6 is equal to, well, let's make that a little bit nicer, Mr. Smith. Okay. Okay, 38 over 6 is equal to B. Okay? So we could check that, right? We could check that. And so I want to. I'm going to just erase this part now. Okay. I'll check it up here. See if it works. Okay. All right. Let's check it. Oh, what color am I going to use? Let's use purple. Okay. So when we check it, we're saying 9/2 equals B minus 1 and 5/6. Well, that's our original equation. Let's start, simplifying this and do the rewrite. First of all, B is equal to 38 over 6. Now you notice I did not reduce this, not yet. And that's because I know I'm going to check it, and this already has a common denominator with this part of the equation here. So I will not reduce it yet, okay? Yes, you should simplify it, but I'm not doing it yet, okay? So 6 times 1 is 6 plus 5 is 11, okay? So 11 over 6, 11 over 6. Let's see how this works out. 9 over 2, okay, is equal to, let's see, that would be 38 minus 11 over 6. Okay, let's continue up here. 9 over 2 is equal to, that's 27 over 6. Now let's make a comparison about reducing here, okay? Let's go back to a little bit of this green, okay. Now look, what number both divides into 27 and 6? A 3. A 3. Now look what happens. 9 over 2. What's 27 divided by 3? It's 9. And what's 6 divided by 3? It's a 9. Or it's a 2. So 9/2 equals 9/2. So now I can go back here. I'm so sure that my answer is correct. Now I'm going to reduce this. So 38 over 6. Well, I'll divide this by 2. I'll divide this by 2. I knew to divide by 2 because they're both even, right? When your numerator and denominator are even, obviously a 2 will go into both. All right, so that's equal to 19 over 3. And how many times does 3 go into 19? Well, 3 goes into 19 6 times. Whoops, don't need to draw a line there yet. Hang on there. Okay. 6 times 3 is 18. That's what we subtract. And we left with a remainder of 1. So this becomes our new mixed number part, and then the remainder goes on top. So that's 1, and that's 3. Okay, that's it for now. Hopefully that was of some help to you. Don't forget to call me or email me if you need some extra help. My office hours are 12:40 to 1:30 every day, and I'm available to help you guys. Okay, talk to you later. Bye.